Hi everyone. This is a video on finding a confidence interval for a population proportion. Now I've already given you another video to watch. However, I made that for previous course where we were using a little different book and a little different symbolism. So I just want to go over a little bit of what we've been doing in our class. So um, what is a confidence interval? Well, let's start. It's always good to start with a question. So let's close this out for a second. Let me close this. Okay, here we go. Okay, let's say, and what I'm doing here is, if you look at your classwork number 23, I'm doing problem number 4 here together on this video. And so you can follow along with your homework. And what we have here is, says, in a random sample of 192 college students, 129 had a part-time job. Okay, so obviously somebody did a study and they found out that that um, that 192 students, college students, 129 of them had part-time jobs. So we want to figure out, we're going to use that random sample to help us come up with basically an estimate of the true population proportion, or in other words, um, what is the true percentage of, what is the true percentage of students, community college students, that have part-time jobs of the entire population that have part-time jobs. And so that's what we do these intervals for, because it's impossible for us to know the actual true percentage to 100% certainty, because we would have to ask every single college, community college student in the country, and that's not realistic. So we use samples to help us draw conclusions about populations as a whole. Part-time job. Okay, so I'm getting a little messy here, but you get the idea. Okay, so how do we do that? Well, we construct a confidence interval. All right, so I'm going to close this for a second, and I'm going to open this up, and I just want to review some steps that we've kind of talked about in previous videos, but here we're sort of putting it all together on how to create that confidence interval. So let's go to here, and let's start with the first step. So the first step in finding a confidence interval, let me just do it right here. Here are all our steps right here. You can copy them down, or you can put them in your notes, or you can just follow along and do this problem together. The first thing we need to do is define our n, our p hat, and our q hat, all of which I think you have a pretty good idea of what our n at this point you know is sample size. So what it was the size of the sample that we asked. It was 129 students. I apologize, 192 students. So n equals 192 students. Okay, what is p hat? Well, you're used to p and q. They are probabilities of a success and probabilities of a failure. We're adding now what we call a hat, which is just a way of saying that it is the percentage of successes for our sample, as opposed to a regular p without the hat, which means the percentage for our population as a whole. So our percent of successes, this is percent of sample successes. Okay. And in this case, what is a success? A success will be having a part-time job. A success is having a part-time job. Okay, and we know that 129 students had part-time jobs out of our 192 students that we asked. And if you do that on your calculator, you're going to get a percentage, or a decimal, of 0.67. So 67%. We can carry it out one decimal place further, 0.672. 67.2% of our students that we asked have part-time jobs. Okay, so what about Q? Well, that just means, you know how to do that. 1 minus the 0.672. In other words, what's our percent of failures for our sample? That works out to be 0.328. You can do this on your calculator. Okay? And that's step one, just defining everything. Okay, let's go to step two, which tells us to check our conditions. All right. All that means is in order to find a confidence interval, right, we're doing confidence intervals here, you have to have a sample size large enough for it to have meaning. If you don't ask enough students, if you only ask 2 students, it's hard to draw a conclusion about the population. So in order to create a confidence interval, we have to have some basic conditions that must be met. One of which is basically the number of successes, at least 10 successes and 10 failures. And so our number of successes is going to equal n times that p hat. And in fact, you can do that on your calculator, but you're going to find that you end up right back at this 129. We already know how many successes are. There are 129 successes. All right, and that is in fact greater than 10, so that condition is met. But we also have to confirm that the number of failures exceeds 10, and that comes from the number that we asked times the percentage. And if you were to take n times the q hat, or you can even just subtract your total number of students. You asked 192 students, and 129 of them had part-time jobs. So how many of them didn't have part-time jobs? Well, 63 of them didn't. And that is also equal to greater than or equal to 10. So our conditions are met, and we can move on. All right, so the next step is to go ahead and do some computations. Because remember, what we're looking for is an interval. We have here, if I just draw sort of a scale, we have here a sample where somewhere in here, so right around here, we have a p hat, which is our sample of 67% approximately, roughly 67%. And we're trying to find the interval in percentages. Somewhere in here, the true percentage lies. Somewhere in here, somewhere in this interval, we want to be 95% certain that the true population of the entire community college population, the true percentage of students that have part-time jobs, lies within this range. So what we're really looking for is this number here and this number here. And if you remember from previous videos, that means we have to find some kind of error. We have to find the error that tells us how far out, how big our interval is. And then we add that error to the 67 above it and the 67 below it, and that's how we get our range. All right, so that's what we need to do now. Well, the first thing we need to do is find that critical value. So go back and watch those previous videos if you have trouble remembering. But our critical values come from our confidence level, and we want a 95% confidence. So a 95% confidence equates with a critical value. And if you watch some of the previous videos, you're going to notice a different book. We talked about the alpha over 2. That is the same thing as the small c that we're using now for this, a lot of our materials in this course. And they're the same thing. Just both mean critical. These are just z-scores for the critical value. How many standard deviations above and below the mean is that 95% confidence? And it's roughly 2. If you remember, 95% of the population lies within 2 standard deviations. But when we use our z-table and we get more specific, it's specifically 1.96, a little bit less than 2. All right, and if you have trouble with where that number came from, be sure to go back and watch some of the previous videos. But you can look on your z-table for that. All right, so we found the critical value, and now we need to compute the error. What is this error? How far above and below from our sample will we go? And that just comes from this critical value, which is 1.96, times the square root of, and this is really just, we've used this formula many times in different forms, but it's our p hat, which is 0.672, times our q hat, which is 0.328, divided by our sample size, which is 192. Now be very careful with your calculator. I suggest doing everything under the square root sign. Multiply these two numbers together, divide by 192, take the square root, and then multiply that by the 0.196. If you don't get the same answer as me, please be sure to come see me, and we'll make sure you're using your calculated correctly, but you should end up with 0.066. So if you think about that in terms of percentage, that's about 6.6% of error. 6.6% of error, but that's our error. All right, that's how far. That's that 0.066, or in other words, 6.6%. That's the error. That's how far above and below our sample we need to consider that the true population is. Okay, so there's our error. All right, after that it becomes pretty straightforward. We just have to find now the interval. We have to figure out that error above the sample and below the sample, and that's where our true, remember this, these signs here mean betweenness. This is how we write betweenness. Our true population percentage is between. It's somewhere in between these two numbers. So if we take our sample percentage here, of 0.672, and we subtract off the error, that's going to be the lower end of where our true population is, and we take that same sample percentage of 0.672 and we add the error, we will get, this will work out to be 6.606, and this will turn out to be, this one over here will be 7.738, and we will write that as an interval like this. And that is what we call our confidence. That's our confidence interval. Confidence interval, or sometimes you'll see it written as CI. That is our confidence interval. And what does that mean? Let me grab another color here, but if I put this here, it means that here is the value of 0.606. So in other words, about 61%. I'm going to write this as a percentage just so that it has a little more meaning for us. All right. So about 61% here. And over here, the upper end of our interval would be about, moving that decimal point, about 74%, right? So if our sample was 67% have part-time jobs, in the end, our sample told us that 67% of students have part-time jobs. Then we can conclude with 95% confidence that the true percentage, which is somewhere in here, the true percentage of the entire population of community college students that have part-time jobs is somewhere between 61% of students and 74% of students. So how do we write that as a final sentence? Because that's step 5 is write your conclusion. Let me just go ahead and put it down here so we have it all on one page. And we will state it as we are 95% confident that the true population proportion of college students with part-time jobs is between 60.6% and 73.8% of students. Okay, and that is your conclusion. And that's how you do a full 5-step to find a confidence interval. All right, so go ahead and try the rest of the problems on classwork number 23. I'm sure you'll be very successful.